everyone. Welcome. And we're going to be looking at sets today. And we're going to look at subsets. Now, when we look at the word subsets, we see this prefix here, sub. And sub would, when you hear the word sub, it tells you about being a part. Sub means a part. Now, under subsets, we want to identify and construct subsets of a given set. We also want to calculate the number of subsets in a given set. Now here I have the set M. The elements of M are Roy, Ray, and Ron. How many elements can be found in the set M? 3. So I can write the number of elements in the set M is equal to 3. This 3 is called the cardinal number of M. So I put an arrow and I say it's the cardinal number. Now let us construct some subsets of M. Now imagine M is a class that I have. And I'm teaching the elements or the members of M karate. Now one day, if it's bright, the sun is out, and there's transportation, everybody's going to turn up to my class. So I'm going to have the set M, the entire set. I'm going to have Roy, Ray, and Ron. All 3 of them are going to come. But let us say that the wind is blowing and the rain is falling and Georgetown is flooded, totally flooded. My class exists, but nobody turns up. So what do I have? No. An empty set or a null set. So I have an empty set. Nobody came, but I still have a class. And my elements or students are Ron, Ray, and Roy. Then Roy and Ray falls ill. Who would come to my class? Ron alone. And then another day, Ray has to go to the airport to pick up his father. And Ron is not feeling well. So who would be in my class? Roy. So I'd have Roy. And then the next day, I can't have Roy and Ron to come. So only who will turn up? Ray. Then I just get closer and closer to the end of the class. Roy stays away. So who will I go and meet in the class? Ray and Ron. Then Ron stays away. So in my class, I would have Roy and Ray. Then Ray stays away. Who would come? Roy and Ron. And there are no other situations in which they would appear. So one time, all of them are going to be there. Another time, none. Another time, only one. And in other times, we'd have them coming in pairs. And all of these are subsets or part sets of the set M. Now let us see how many subsets we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. Let us go again. 1, 2, 3, 4, 5, 6, 7, 8. So when we have a cardinal number of 3, we will have 8 subsets. Good. So we can write here that M is a subset of M because one day everybody's going to come. We can also write the empty set is a subset of M. And of course, we have all these other subsets. But you must remember that the set itself and the empty set are always subsets of the given set. Good. Let's go. We have the set X, A, B, C, and D. We have the set Y, B, and D. Now, when we compare the two, what do you notice, Himala?
We have different elements inside. X has 4 elements inside, and Y has 2 members of X.
X has 4 members, Y has 2. And what Himala noticed is that all of Y are in X. So we can say Y is a subset of X. What we also notice is that when we look again, everything in Y is in X. So we say X contains Y. Now let us look at P and Q. In P we have 2, 4, 6, 8. In Q we have 1, 3, 5, and 7. Now when we look back at X and Y, we see that Y is a part of X. Y and X have elements in common. They share elements. Now when you look at P and Q, do you see any element in common? No. So we call P and Q disjoint sets. Disjoint sets. And why are they called disjoint sets? Because they have no element in common. Now let's proceed. We have 1, 2, 3, 4 sets here. We want the second column, the number of elements in the set A. How many elements are in the first set A? None. How many in the second set? 1. Then this one would be 2. And here we would have 3. And all of these here are called the cardinal number for these here. The cardinal number of the third set is 2. The fourth set is 3. Now we want to see if we have set A with no elements, how many subsets we'd have. And the same thing for the others. Now if we have set A with no elements, how many subsets would you have there? What should I put here? The empty set. Let us take the second one. We have 1 as an element there. All the subsets that we can make for this set would be? What are they? Empty set and the set itself. So when it's no element, how many subsets we have? When it's no element in the set, how many subsets we have? 1. When it's 1 element, how many subsets? 2. When it's 2 elements, it would be 3 subsets? No. Well, let's find out. Let's make the subsets first. So what's the first subset? Empty set. Second one? The set itself, which is 1 and 2. What's the third one? 1 alone. And then we have 2. How many subsets? 4. So we have 1, then 2, then 4. And we have 3 elements. See the pattern? 1, 2, 4. What's the next one going to be? 8. You're going to make the subsets, and I'm going to put the number. Did you get 8? Yes. So you have the empty set, the set itself, so that would be 2, 1, then 2, then 3, that would give us 5. Then we'd have 1 and 2, 1 and 3, and 2 and 3. Now when we have no element, we have one subset, one element, two subsets, 2 elements, 4 subsets, 3 elements, 8 subsets. If I had a set here with 4 elements, how many subsets would I be having? 12. You certain? We're trying to develop a pattern here. 1, 2, 4, 8. What do you think, Miracle? Miracle thinks it's 16. You think it's 16 too, Imala?
Yeah.
You think it's 16 too. What do you think, Keisha?
I think it will be 16.
You think it's 16. Quincy, you see the 16 anywhere around? Okay. So the number of subsets would be 16. So what we're doing now, we're comparing the cardinal number with the number of subsets. So we're looking at this one, and we're looking at this one. So if we're given the number, we don't want to always be listing the subsets. We want to know that if we have a number here, we know immediately, okay, we're going to have so many subsets, and we want to be sure about it. So how can we look at this pattern and write one statement that we can always use to find the number, to tell us how many subsets would be in that set? When you look at 1, 2, 4, 8, 16, and then you look at 0, 1, 2, 3, 4, and you think about, we're going back to algebra, and you think about bases and powers, or you think about the index and the base. How can we write a statement in such a way that we have this, we have that, and it indicates to us that, yes, this is the number. Yes, Quincy?
So it can be 2 and a raised to the power of the number of elements in the set.
Mm-hmm. And what will be result?
Number of subsets.
So let us take 0. Quincy suggested we take 2, raise it to its cardinal number, the 2 raised to the 0 power, and out should come the number of subsets, 1. Is 2 to the 0 power equal to 1? Yes. Now, that's only for the first one. Let's try the second one to see if it holds true. Let us take 2 to the first power, and let us see if we'll have 2. Is 2 to the first power 2? Yes. And will 2 to the second power be equal to 4? Yeah. And if we keep going, you see the pattern, so we can come to a generalization. What changes? This up here changes. The power changes. And because the power changes, we're going to make it a variable. So we're going to write 2 raised to the n power would give us the number of subsets. Okay? This is what changes. Every time the number of element changes or the cardinal number changes, this n changes. So we come to one theory. 2 raised to the n power gives us the number of subsets. Good? Now this saves us a lot of time because all we need is the cardinal number. And I can tell you how many subsets you're going to get. I don't have to go list and then count them up. Good? So let's quickly recap what we did today. A subset is a part of a set. In going through it, we found that the set itself and the empty set are always subsets of the given set. Always. If we want to show the relationship between two sets, one belonging to the other or one contains elements of the other, we can write y is a subset of x. We can also write x contains y. But we can only use this one here when all of this would be in here. Okay? Good. If sets have no element in common, if they don't share any element, we call them disjoint sets. And we also found that if we have the cardinal number of a set, we can use that to predict or to tell how many subsets we're going to have from that set. Now let us recap quickly. Look here. Look.
Lesson 11. Sets, subsets. In this lesson, we will identify and construct subsets of a given set. We will also calculate the number of subsets in a given set. A cricket team has 11 players. Within the team, there might be 3 groups of players. One group might be batsmen, bowlers might make up the other group, and the third group might be all-rounders. Each group forms a subset of the set of members of the team. A subset is a set contained within another set. The captain might want to talk to all the members of the team as well as to each individual group. The captain may choose not to talk to any of the groups. The null set is also a subset of the set of members of the team. Here are some key points. Given that the set B is equal to 0, 1, 2, B is a subset of B. The empty set is a subset of B. 4 is not a subset of B. The number of elements in set B may be written as. Compare and contrast the sets A and B. The set A is equal to 0, 1, 2, 3, 4, 5. Set B is equal to 1, 2, 3. B is a subset of A. A contains B. Disjoint sets. Two sets are disjoint if they have no elements in common. Example, A equals A, B, C. And the set B equals 1, 2, 3. Let us examine the subsets of given sets. Set A, number of elements in the set A, subsets of A, number of subsets. Empty set, no element. The subset of A would be an empty set. Number of subsets, 1. A, number of elements, 1. Subsets, empty set, and the set itself, 2 subsets. Set A, B, 2 elements, 4 subsets, and subsets are the empty set A, B, and AB. Set A, A, B, C, 3 elements, empty set A, B, C, AB, AC, BC, ABC, 8 subsets. Set A, A, B, C, D, 4 elements, subsets of A. Number of subsets, 16. Let us compare the cardinal number of the sets in the previous table. Number of elements, number of subsets. No element, 2 to the 0 power equal 1. One element, 2 to the first power equals 2. Two elements, 2 squared equals 4. Three elements, 2 cubed equals 8. Four elements, 2 to the fourth power equals, is there a pattern? 2 to the fourth power is equal to 2 by 2 by 2 by 2 equals 16. Note, the number of subsets of A is equal to 2 to the n power. N tells us the number of times 2 will appear as a factor of the repeated multiplication. Example 1. If x is equal to 0, 1, 2, write down all the subsets of x. Solution. Empty set 0, 1, 2, 0, 1, 0, 2, 1, 2, 0, 1, 2. Example 2. Mark claims that the sets S equals ABC and R equals FGH are disjoint. Do you agree or disagree? Solution. Two sets are disjoint if they have no elements in common. Example 3. Which one of the following shows the relation P is a subset of Q? A, B, C, D. Key. A. Summary. Two sets are disjoint if they have no elements in common. The empty set is a subset of a set. Example. The number of subsets in a set of n elements equal 2 to the n power. Problems for today. Page 28, exercise 3b. Questions 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Mathematics for Secondary Schools in Guyana, Book 3. Solutions for problems given in the last lesson. Page 26, exercise 3a. Rewrite using set builder notation. 4. The set of integers less than or equal to 6 but greater than or equal to negative 3. 8. Whole numbers greater than 7. Solution for the problem given in the last lesson continues. By inserting the inequality sign, use set builder notation to describe the set where u is equal to z. 12. 0, 1, 2. Use a sentence to describe each. 16. The set of integers less than 3 but greater than negative 3. 20. The set of integers less than or equal to 7 but greater than negative 6. List the elements of the set given by 24. B equals to 0, 1, 2, 3, 4, 5, 6, and so on. List the elements of the set 28. 1, 2, 3, 4, 5, 6, 7. Lesson. Solution for the problems given in the last lesson continues. If x is an element or member or set of integers, list the following sets. 32. The set A is equal to x such that x is greater than or equal to 0, less than or equal to 4. Answer 0, 1, 2, 3, 4. Given x is an element or member of C, calculate the lowest and highest values of x for the following. 36. X is greater than negative 8, lesser than 4. Negative 7 and 3. State whether each of the following is finite or infinite. If the set is finite, determine the cardinal number. 40. 0, 1, 2, 3, and so on to 8. Finite. Cardinal number 9. 44. The set of m such that m is greater than negative 7, lesser than or equal to 7. M is an element of the set of integers. It's finite. 13.
And as you go through the door, you're going to go making subsets. Look around you, identify a set. Then look within the set and make little parts of the set. So I know you're going to go through the door today, and you're going to go out there looking for sets all over. And then you're going to use all the different situations and make subsets. Okay? And I hope that you can use subsets to your advantage. You had a good time today? I hope you enjoyed all that we did. I'll see you next time.